Hello, hello. Another episode of Agentic AI in DevOps with Andrey, Fernando, Vladimir, bringing you the difference between semantic layer and the context layer. What are those? Why would you should need one or both or maybe none? Let's figure it out. So boys, semantic layer. Just before we pressed record, Vladimir was saying that he actually spent a little bit of time, well, maybe even more than a little bit, building semantic layer. And I guess he's very well positioned to explain us what is it, semantic layer is.
Talk more about it's more both about the labeling actually, but in my case in particular, it was related to a knowledge which is not exists in the public domains where all the LLMs read the data, process, and learn from. And sometimes, in my particular case, things mean different things. It was about the database schema and database tables, and a couple of names was used in the wrong way. It was a mistake in the early stage of a 5 years old database, and we supposed to explain LLM, but when they read, for example, users or something, but it's not the users inside, but it's something else. But it was a mistake, which is hard to change in the real database. It's just easier to explain LLMs. So this is at least how I understand the semantic layer. When you explain the different terms here and there, again, it's quite closer to data labeling because you put the labels and explain what it is. So in this database context, you have to explain what does a table mean, what does the columns mean, what does a function mean, what does the view mean. Basically, you have to explain everything because without that information, AI start guessing and of course guess wrong. It doesn't know what is inside. You have two options in the database case. You can provide the whole database to AI to read each time, or provide any kind of layer of information in advance so it doesn't need to process the whole database.
It's a translation layer, basically. And
one way or another.
In most cases, like the most frequent application of that where you would see it would be a business intelligence, because the business models of the companies are structured differently. They put different emphasis on the different numbers, and the data might be structured in the ways it did it. So in order to talk to your data and apply or any other kind of system to your data, you need to have this translation layer that explains the rules and the way how data is, where's the data and how to interpret it.
Yeah, we can come to as any kind of acronyms. If your company use any acronyms which understand that only in your company, this is the thing. So if all of your companies speak as, I don't know, BAD, and everyone know what does it mean, but AI maybe know something else. So this is also a part of a system which was created. We have to provide explanation to all the acronyms, whatever internally is used, and what is actually is for that particular company. And in general lingo for people, sometimes they say something in the short forms and whatsoever. We have to provide everything in advance so AI can understand what people mean.
Yeah, that's an interesting one indeed, right? For a lot of things that are not public domain. And curious, how do maybe in the projects you work, Vlad, how does AI consume that layer? Is it something yeah, actually, that's my curiosity. How do you embed that layer into the flow, right?
Yeah, you can embed it in a different ways, or rather, as you can gather the context. Sometimes that works also well, but usually it's injected in the moment when AI try to understand what this question is about. Because first time user send a question, and we need to understand what components of the system which we are going to query is involved in that. So basically, you need to understand which tables or which columns or which views to use to add, what is the best guess basically. So it's best guess is use these columns, tables, and so on to help the user, and also to explain later AI agents how to describe these acronyms or what user actually mean in the first question. So this question processing, it's maybe the first thing. And when later deeply, we also have to consult time to time in some sub-agent's behavior, like are we are on the right track? Because sometimes we're researching something and we need to double check if we go the right direction or not, because AI may go the wrong ways time to time. So we can just double check what is, this is the right users, this is still mean this. So this is also the place to use this context layer.
There are many data analysis products on the market that kind of does that.
Of course.
One of the very frequent use cases is dashboarding, like with AI, where you like using that for conversational analytics, Databricks, Looker, and there are plenty of products on the market.
It's it's selling like you don't need your analytic or whatever department anymore. You're a CEO, you can just ask your data directly. This is how people sell it. But in reality, of course, you need your team in place because someone needs to structure and label the data still and guide the AI around.
Yeah, it creates a huge danger, right? Of like, you don't need the people who understand your data. You just ask and AI gives you wrong advice, but you keep believing because it's so like a believable advice, right? But
it's very tricky.
It's an interesting one. Okay, but then I understand like framing a model on when to put this into place, like when you need AI to understand particular knowledge, right? Like something that's really target to your ecosystem. Nice.
And especially when you can't put all the possible data in the context of AI, like in databases. You cannot just scan millions of records or terabytes of data and put everything in AI. Just not possible by the limitations. Or it's going to be very expensive. I don't know. I can't say it's not possible. Everything is possible in today's world.
Yeah. So that brings us to the context layer and the differences between them. And soon you're going to see why it's confusing to many people. But just to formalize a mental model here, semantic layer basically explains what is it you have in your database, like what it is and like why it's there. With a context layer is you basically, like if you stick with database context, right? It's what in database, like the content
So
of the
it's the
database.
data itself, right?
Yes. Let's apply this to our field of infrastructure and like the DevOps and automation. So imagine you are using Kubernetes, a very rare thing that people do, but like imagine you're using Kubernetes. You don't really need to explain LLM to LLM what Kubernetes is, like what the pod is, what deployment is, what ingress is. It already has this knowledge in its database, and people don't build their own Kubernetes in the companies. So Kubernetes in one company gonna be 99% equal to Kubernetes in another company. There is no ambiguity about those. Deployments will be deployments. They might use different configurations inside, but the data model of Kubernetes will be mostly the same unless, the Kubernetes allows you to actually extend it and define your own object types. This is where semantic layers comes in. You start defining your own data types. LLM has no idea what you got there. So you need to explain it. You see manifest saying firewall or whatever, Cisco router. Like, I don't know, come up with something.
Yeah, easy. CI version 11.
Whatever.
Or temporary fix of December.
Yes, so like there's some data types that is not part of the Kubernetes data type. That will not be an LLM zip file or like the knowledge cutoff thing. So it needs to have an explanation what that is. Otherwise, it's going to guess. It's going to make its best guess, like what it could be. But the names, like what the hardest in the software engineering is naming. So the developers are notorious in picking the bad names that mean completely different thing from what the thing does. And this is where LLM will get confused. Right. So this is like application of semantic layer idea to the DevOps. Now, fine, we have a semantic layer. So we explain to LLM, like in most places, like what people usually would do, they would write skills and say, like, that's what we have, skills. But then you could have a database of where things are, because you could have those things that you define, but each time LLM starts, it has no idea unless you have a memory enabled, so it will have a little bit of idea. But basically, you would have to tell where things are each time and guide LLM to get it like and write skills. So the context layer is basically a map of everything you got. Semantic layer explains what you could have and what does it mean. And context layer is where to find it. And again, usually context layer will come with filtering capabilities, meaning that the LLM agent will be able to search. So it will not get all of the context layer at once, because that's a lot of data, which it doesn't need. And you have a limited context window to work with. So you need to formulate the query, send it over, get the appropriate context, which is properly sized, start execute on that. So this is where the magic happens. And there is a research that we're going to link in the show notes. It's nothing new. I think like there was like a newer papers, but there were papers 2 years ago where people show time and again that you can have a smaller model paired with a context and semantic layer, and those will perform better comparing to the bigger models. They will give you a higher accuracy answers, and your agents will work better if you have this knowledge, because context is the king.
Yeah, and have a smaller model that is a lot more targeted, right, to a certain type of task with the right context and the right semantics, then it does make sense that the quality would be better, right? But then it's that is a nice way, I think, for those that are listening and thinking like, like how do I use this? Then indeed, the context will help you, context layer, to help understand what you have in your infrastructure, right? And if you do have things that are not that so common knowledge, then you might need a semantic layer as well to kind of give meaning to those things that could be custom constructs that you invented in your own environment, right? Which we do find a lot as we work with customers, and then you find interesting things that people come up with that then you need to try to understand. And then, as you said, Andrey, AI will try, and Vlad as well, like to guess what it is. And then sometimes making decisions based on those guesses, right? And then you get a very wrong outcome based on what you expected, at least.
I actually recording demo today or tomorrow, but since it's a podcast, you would need to use your imagination right now with me, and I will try to be as descriptive as I can. But imagine the terminal in front of you. Okay, you have your harness of choice: Codex, Cloud Code, PI Dev, Open Code, or any other of the millions of those available out there, with the model of your choice, which doesn't really matter. And you have this service of yours that you know how it's called. I don't know, like let's call it pizza order something. It runs in your development, staging, and production. That would be like AWS accounts. And you say like, well, check if there are any errors for pizza order in production. You just type it in the terminal, and your typical harness will be, all right, what is this? So semantic layer, like it needs to understand, like it actually need to combine semantic and the context here. It would start like, okay, like I remember we used AWS before. So let's look around. And it will go and look around in accounts, trying to list the kind of services, what the hell you might mean. Maybe eventually it will find it, 100K tokens later. If successful, it actually finds the account and manages to list the logs to realize that your logs are actually in Datadog and not in CloudWatch.
Yes, and a billion grabs in between, as you see, right? Looking for files. True.
And that's pretty much what needs to happen every time, unless you write the specs, like documentation for your LLM, say like, we use this, it is there, blah, 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 blah. And like as things are changing, you need to keep updating your documentation. The context layer that we actually built, like with Boris, that's what like I'm recording demo for. It basically starts by MCPing to Boris, saying like, Boris, like, what is this? Boris says, okay, this is most probably ECS service that runs on this account and this feature. This is how you can get the logs. Like basically 1 or 2 calls, it gets all the context it needs, and then it starts to query the logs and giving you answer like much faster. And the context layer keeps all this information up to date, plus like with dependencies. So like all the heavy lifting on figuring out dependencies and how things are connected to each other already done. So your agent kind of comes to the ready-to-use answer, allowing it to move much faster. You still have much more context in your session save available for you to work on. And like the danger with the memories, like agent memories, like right now, most of them coming with the memories, they're coming stale. So they're not being updated all the time, and they actually might be a blessing, but it might be double-edged sword. We discussed that, like when we spoke about the memories. You really need to have a good way of forgetting things and validating against the reality. So the context layer is actually a better thing, because those memories, they might introduce the bias of the model. Like you're not getting the pure experience every time. Experience starts to be being affected by the memories of the previous interaction, which is good and bad, because that will tilt the model in a particular direction, comparing to if you're using hardness that has a memory-free session each time and just loads the relevant context each time. This, in my opinion, is better. And I think all the people will try to build the same, or they can try to go use Boris.
Yeah, no, I see. This example that you gave about the memory is something I experienced so much. Like I used to use Claude AI, not even for the DevOps things, right? But for like the day-to-day stuff. And the memory started to pollute so much my sessions that I had to like put in the prompt, don't look at the memory, use this as a raw session. And then it still would like try to, and then I start using like a Claude Code to do the regular stuff, because then it's a fresh session. And there I only load the things that I actually want to. So this makes even for the day-to-day stuff, right? But like this working with stale data, right? It's really bad for what we are doing, because you might make decisions now bringing back to DevOps, right, based on wrong information. And so it's this is the live data thing. And as infrastructure grow, right, like we work with AWS, like you have thousands or maybe hundreds of thousands of resources, it's very difficult to find the right thing. So this kind of layer can really help speed up as we keep expecting an agent to reply fast. I realize this as well as I'm working, even with a local application, right? The application starts to grow, and then you see your sessions start to take very long for the agent to finish something. And it's because there are so many things for you to grab and kind of try to figure out. So imagine connecting to like AWS, right? With all of the different APIs and all of the huge JSON payloads that come back if it just tries to use the CLI. So this is very helpful, right? To stay in the flow.
I see Vlad have his arm raised. Hold it. I just give an example very quickly to what Fernando says. Hold it, Vlad. Just to give an example, like how it would go without. I had to, like this week, I had to deal with a complex transit gateway network, like really complex, a lot of connections, a lot of attachments, complicated networking. So I have first session 200 tokens with Fable 5. So like the tokens go even faster. Maybe I should not have used the Fable 5 for that one. Anyhow, I basically asked it like, go call AWS API, build me the map of what I'm dealing with. Like just build it, save it to file. Second session. Well, now go collect all this data, save it to file. Third session, go collect this, save it to file. Fourth session, like 1 hour later. Fourth session, open all those files, read, now try to make sense of all of it. That's your context. I'm basically collecting context manually because I didn't have access to the Boris in that situation. So that's like a life with and without it. And like everyone doing that today without understanding it or not. Yes, please. What?
I have an analogy to, like I say, memory, without memory, and the context layer at the same time. I'm going to compare it to a generic search in the internet. So you can search in your own account in any kind of search, whatever you use. It starts accumulating your previous search history and start modify your search according to your information which you searched before, your location, your keyboard, or whatever things people use now. So it's going to be a bit biased now, your search. So if you want to reset it, you have to open any kind of incognito mode with different search systems. So this is basically how the memory will affect, in my opinion, our AI sessions. You accumulate something, and now you're going to be affected on that one way or another. But when we talk about the context layer, I can compare it with the same thing, searching, but in your own documentation, which you write for yourself for a while, and you now shoot the same search request, but you get completely different results because it's now including your own information, which you save after a while. So this is just for me, for how I map these things in my head, like as to the pre-AI era to new AI era, just to keep on track and see how you use things. So obviously, to search inside your private documentation, like it's a Notion, Atlassian, Confluence, or whatever, it's much faster because it already exists. But someone need to keep maintain that. It was no one in the past. At least now we have like as a context maintainer, right? Which we include in our teams, these AI agents such as Boris, who can keep maintaining this context forever without you involved, which is cool.
Another analogy would be more like, sentimental, if you like. Many of us don't live in cities where we grow up. It's like the world becomes a little bit global, people moving around. So it's very similar to you coming to the city where you grew up, like after not being there for 10, 15 years. You kind of know your way around, but things look different at the same time. And you're moving through the city, and then suddenly the path that you used to take many times going to school does not exist any longer because they built something there. And this is how memory is tricking you, like your muscle memory. So technically, you would be better off using Google Maps, even in a place where you know. And this is like how the context layer comes in. It basically gives you direction, like how you need to get to the destinations the fastest way. And like even like in the place where you live, I actually, like for instance, time to time, I just double check myself with Google Maps. Like the way I drive, like is it actually fastest? Like I think it is, but is it really?
Yeah, so you use live data to check your memory, right? To see is like, am I still being? But that's a good one. I think as more and more of us use these coding agents, right, to do our work, and I started experiencing this a lot, that you start to being slowed down, exactly for what Andrey was mentioning. Like you need to build all this context, multiple sessions, because you know that one is not enough and all of that. And then thinking about maybe I need a context layer can be maybe a next step, right? To keep that productivity that we are all aiming for, that maybe we got that huge leap in the beginning. Now you're still a lot more productive than you before, but there is also this trend that you might feel productive, but if the outcomes are like I spend hours just gathering context and still the result is not the right thing, then it's just an illusion of productivity, right? And sometimes it's more about equipping your agent with the right information through a layer or something more effective than just like doing raw research, so that you can start to reach closer to that nirvana image that we have, where we are just like delivering things very fast and just managing the agent, right? Like just watching as the agent does a lot of stuff. So
yeah, I just saw the quote from Kent Beck this morning where he says, yeah, typing got faster, thinking not. And I think that's really where we are right now. Like that's like the state of the industry. There is like a lot of people claiming it's magical. Like, let's build dark factory. Yeah, I seen people doing that with different level of maturity, like rolling their own. Haven't yet seen the miracles, really. Like I haven't seen them. If
we will see the miracle if everything become rewritten in Rust.
that is
whole
happening.
World.
No,
yeah,
that is happening.
If it's done, okay, I believe in miracle. Like I said, the whole software in the world become just Rust.
Each time you run brew to install something, it updates the index, and like every day I see this thing in Rust, that thing in Rust, this thing in Rust. There is like a lot of stuff being written in Rust, and I even heard that it's actually taking over Go in popularity.
So it's mean technically miracles are kind of happening, right? So things are going that direction.
We are going that direction, yeah.
But I haven't made the leap. Like the Boris MCP CLI that we released this week, icon on GitHub if you want to take a look, which is a very simple tool that basically translates the MCP calls to the CLI arguments. There are Python projects of this kind, I think like MCP-CLI and so on. I think Fast MCP can also do that out of the box. But most of the projects I seen, they were like Python based. I don't want to have dependencies. So I wanted to have something compiled, but being, beast of the habit or whatever, how they call it, I'm like, well, let's just do it in Go because I understand it.
No, we are preparing because in the future we're going to announce we rewrite it in Rust. And
yes,
get attention.
Info point.
Info point.
Yes, but it's written in Go just because I know how Go releaser works, so I can distinguish between.
It's just faster, yeah. Especially in the modern era of AI, just choose whatever it's faster. It doesn't need to be in a particular technology, just whatever works.
Building CLI, no problemo. Getting enrolled in an Apple development program so you can notarize and sign a binary, that took a long time. And I still had to, do it with my own account, like private account, because like enrolling a company, boy, there's a lot of red tape in there.
Yeah, of course. And I think like as all of these marketplaces, they have to raise the bar a bit because I believe they're under the heavy pressure at the moment because there's a huge amount of software shipped hourly, I don't know, in every minute maybe inside all the marketplaces in the world. So they have to just be a bit more defendable or all the marketplaces will be flooded on the half working stuff, which is I would like to say already in the internet, when you download the tool, you have no idea if it works or not.
That would be a final argument why you need context layer is because you too shipping software faster and more, and no one really knows what is out there right now. I mean, like the amount of software you ship, it's getting harder to track. Like the cognitive load of tracking it is like more. Just because like the developers have, in most cases, have no idea what is actually inside there and like where they shipped it and how often it was. Before that, at least it was happening slower and it was possible to track. Right now, like quite often they would ship it and forget about it because they haven't spent, time doing it being painful. So it would leave the trace in their head because, writing software isn't easy. It is heavy cognitive process that requires a lot of concentration, thinking, and so on. So like when you do something by hand, which becomes more rare now, it leaves the mark. Like you remember doing that. If you just tell the AI, like, well, go do it, in 2 weeks, you don't remember.
And now I'm seeing also like in Silicon Valley, I was seeing some interview and people saying like what's becoming a trend there because all the startup stuff, right? Is like 20 coding agents at the same time. And like people are uninstalling IDEs, like you zero checking the code because there is no, you cannot keep up with all of the pull requests, right? So at a certain point, you're like, you know what? We fix forward. And then you see releases like multiple releases a day because when it's broken, you just fix the bug and you move forward. And I kept seeing it even with the big labs, right? I don't know. This is my impression now, like that the things are moving so fast that you don't, instead of fixing it, I mean, trying to prevent the bug, you just fix and you move forward and you keep using AI to just keep rolling, right? But the cognitive load, it was much, much higher before, right? You couldn't do this. So then now it's a different pace.
In the same post from Ken Beck, he was also saying that like there is like a 5x more incident because of that, and like there's like the bugs are 8x or something like that. I might be confusing the numbers. I will look up the post, but there was like a multiples than it used to be before. So yeah, typing got faster, thinking not, and it's basically just a different tool you got. Like you used to have IDE without a complete. So it's kind of a better autocomplete, but there still needs to be an idea of what's going on and what direction needs to go. Otherwise, if you just like sit and like press stop in 2023 without thinking, you would get not the optimal result that you would be proud of. Anyhow, that was 30 minutes of semantic layer, versus context layer with some software development rumblings in there. Thank you for all of you.
Yeah.
Stay till the end, and we hear from each other next week.
Yeah. See you in the next one. Thanks for tuning.
Thank you.
Bye.
Bye-bye.
Bye.